Researchers at MIT's Computer Science and Artificial Intelligence Lab have possibly found a new way for factory workers to telecommute to work. Essentially, you throw on a virtual reality rig while you're still in your pajamas and operate a collaborative robot or cobot remotely. Using an Oculus Rift headset, the worker would operate the machine, or Rethink Robotics Baxter in this case, in a virtual control room. The display not only provides a view from a camera on the robot's head, but also views from the cameras on the robotic grippers. These are my robotic grippers. So the camera would be like here. Oh, you need to see it? In this particular example, you can see the user trying to put two oversized Legos together. I mean, the video is actually in double time, so we clearly still have a ways to go before, we're making assemblies from our couch. The robot is even capable of using hand tools. In this example, they use a staple gun. Now, the team's approach solves common VR problems, such as delays that cause nausea and headaches, by making it seem like you're actually inside of Baxter's head. Next, the team wants to make the VR system more scalable so that multiple users can operate disparate robots all at the same time. Although I'm not sure that I'm into this, as it leads to a future bereft of all human contact. And I mean, I know that most are into that, but it's just just get out there and see people. Most are good, just it's a person. It's a short one. This one's a big one. It's my people. MOIP! The Offices of Naval Research is working with the Naval Research Lab, Walter Reed, and the University of Michigan to develop smart prosthetics. A common problem with prosthetics is that they simply are not comfortable. They can irritate the skin at the connection point, causing abrasions that can lead to infections. Companies have tried many different designs to improve the user's quality of life, including, for example, using vacuum pumps, which not only hold the prosthetics on, but also increase circulation and comfort. However, this solution is a little bit smarter. They call it monitoring osseo-integrated prostheses, or MOIP. It provides sensors that alert users on potential wear and tear. The MOIP, or MOIP, doesn't connect to limbs like a traditional prosthetic socket. Rather, it uses an osseo-integrated prosthetic, a titanium fixture that is implanted into your bone. Bone actually grows around the implant, which is what they call the osseointegration. But it leaves behind a small metal connector that provides a more stable connection with the prosthetic. Because the metal sticks out of the leg, it is at a constant risk of infection. So the MOIP system also focuses on detecting and preventing infections. Essentially, the researchers put a smart skin on your limb that couples with sensors on the prosthetic. The array tracks changes such as body temperature to monitor for possible infection. It will also sense things like how the bone is healing around the implant, which would help speed recovery time after surgery. Intelligent prosthetics could be the next generation of devices that not only improve the life of soldiers wounded in combat, but also for the millions of Americans who live with amputation. While the prototype has been successfully tested, the team is now working on next generation models that will be used in clinical trials in 2018. MOIP! How do you get the biggest aircraft in the world off the ground? Well, it helps if you use composites instead of metal. Although when it comes to Paul Allen's massive aircraft, it technically hasn't left the ground yet. So, how do you most likely get the biggest aircraft in the world off the ground? Composites. Scaled Composites, the manufacturers behind the Stratolaunch, the world's largest all-composite aircraft, used hypersizer software from Collier Research to automate design, stress analysis, and sizing optimization. Stratolaunch is not only the world's largest aircraft by wingspan, remember it's wider than a football field, which seems to be the universal comparison for it's really big. But Stratolaunch is almost entirely made out of composite materials. The aircraft has a pair of fuselages that are connected by a giant single wing. It is powered by the 6 engines that the company recently test fired out in Mojave, California. The first launch should come as soon as 2019, but it's going to take a lot to get this aircraft up in the air with a 550,000-pound payload. It needs 28 wheels just to get around on the ground. Using the hypersizer optimization software, Scaled Composites fine-tuned the aircraft's fuselage and wing structure. For example, deflection limits were a significant factor to be taken into account. The panels of the dual fuselages were sized for strength, stability, and honeycomb sandwich failure modes. Through the use of the Hypersizer software, the stress team was able to use automated failure analyses, which provided everything from free body analysis and discrete laminate sizing to ply-based composite failure analysis and honeycomb sandwich analysis methods. According to Collier Research President Craig Collier, oh, I get it. This type of software helps figure out if structures are producible and identify any manufacturing issues. Well, here's hoping that they catch any and all of them before this thing flies. I'm David Manchi. This is Engineering by Design. Oh, I get it.